Good afternoon. I'm Brendan McAdams. I'm going to talk today a little bit about ScalaZ gateway drugs. One of the things that I've said a number of times over the last couple of years is that we are not using the Z word. We're just going to avoid this. We're going to avoid this whole conversation, this whole argument. We're not going to talk about ScalaZ because it's just going to start a holy war or whatever else. Unfortunately, it seems like I lied just a little bit. I've gone down this road. I've started to use ScalaZ more and more in the work that I do. And I want to talk about how this can be useful. I want to look at a couple of different pieces of ScalaZ that you can use to get your stuff done that you may find powerful. And so in the past, I've looked at ScalaZ as pretty intimidating. There's a lot that's there. There's not a lot of documentation necessarily. You're sort of relying upon either figuring it out on your own or finding other people who know things that can feed that information to you. And it's always spoken about as being pure, Haskell-y, mathy, that you kind of get this impression that you need a PhD in computer science in order to get anywhere with it. It's not actually true. There's a lot that you can get done if you find the right building blocks. I am not great at math. I don't have a CS degree. I'm a self-taught programmer, and so for me, I was really intimidated. And once I got going, though, it became easier and easier, and each piece makes more sense. And of course, the question that we all ask is, what's wrong with what I have in standard Scala? It's a reasonable enough question. We're going to look at least at one piece and how to solve a certain set of problems. So the reality that I've come to discover about ScalaZ and similar category theory libraries is that they're magic. I mean, there's a lot that's there, and you can almost be amazed at how quickly you can get things done that were very, very difficult before because there's these great building blocks that all tie together. So once I got started with these tools, it ended up being pretty hard to stop. You want to keep finding more and learning more and going down that road. The constructs that are there are really powerful and they're very useful. But I am not an expert. I'm not going to stand up here and argue that I'm a ScalaZ expert. I'm a beginner who's made a lot of progress and can show you a couple of tricks that I've come up with to help you go down that road yourself if that's what you want to do. I'm not going to talk about math or category theory or Haskell. I might mention a couple of words like the M word. We'll try not to go too far down that road. So what I want you to learn, and the only thing I want you to learn, hopefully is, hey, this stuff is really useful, or it might be useful, or I might be interested in learning more about this. I don't want you to learn that a monad is a monoid in the category of endofunctors, because that's not the subject of what we're going to discuss. So the road that I went down, what got me started on this, was providing clear errors and validating input. I was working on an API server. It was part of a larger application. So we had a Scalatra Scala server and a UI that was built in AngularJS. And so what would happen is we would build REST services with Scala, and the Angular UI would consume those REST services. So passing errors was really difficult. What happens when something goes wrong? How do you communicate that both in production so that the UI can communicate effectively to the user what's happening, but most importantly in development? Are you in a situation where you constantly have to troll through error logs in order to answer a question for a UI developer about what happened, or for someone who's consuming your service? Because if you're throwing a 500 error, that's really all you're doing. You're throwing an exception, you're throwing a 500 error. You're not telling people much about how to solve the error that they got. So if an error occurred, did the API receive bad or invalid data? A big one that I ran into was the JSON failed to parse. Well, can I communicate that up the stack? Or do I just throw a 500 error and then dig through error logs and scratch my head and go through all of these different things? Or the database failed. Well, let's face it, I don't probably want to throw a SQL exception, but I'd love to extract some information like that entry already exists in the database. And what if multiple errors occurred? What if lots of things happened and I need to accrue information about those things in order to communicate effectively something to help people solve problems? And how do we do that effectively? So there is a construct in Scala that we could probably use called either or either, however you want to pronounce it. With the built-in either, it's a pretty commonly used tool. It has a left projection and a right projection. The convention says that left is an error and right is a success condition. So you have these two sides of a disjunction that it's left or it's right. It's an error or it's a success. It's a good concept, but interacting with it in Scala is not ideal for the kinds of things that we might want to do. So I instantiate an instance of right with the with success in it, and I get back an instance of Scala util right. And there's a function I can invoke on it that's isRight, which tells me if it's right or left, because ultimately they all are part of either. And success is left will come back false because it's not a left, it's a right. But I can't iterate over this with a for comprehension because it's not a monad. So you do have the ability to do things like call right projection, which will turn it into a right projection and allow you to iterate. But it's not ideal. I should get this out of the box. I should get something out of the box that allows me to work with this information. And so now it's time for the Muppet Show, or to talk about ScalaZ in reality and to look at some of the tools that we can use. So one of the options is a disjunction, which in ScalaZ is \/ And I know I've already gone into symbols and it's getting to be a little bit hairy. The word that you probably want to use to describe this rather than v or \/ is disjunction, because that is what it is. In ScalaZ it's defined in either.scala, which probably isn't useful to call it either or either because there's already one in Scala. So we'll call it a disjunction, which I think is a common term that people have agreed upon, or at least if you call it a disjunction, someone will know what you're talking about. And with the disjunction in ScalaZ, it mostly assumes that we want a right success value, that we are looking for success, which means we're looking for the right. This is also known as right bias, that when we do things like iterate over it, it tries to extract a right-hand value. So we can unpack this. I can use a for comprehension or a map statement or a flat map statement where the positive value, which is \/ continues, and the negative value, which is \/ aborts. And again, we're at those symbols. The easiest way to think of things is which side of the disjunction the dash is on, because that's left or it's right. And so this indicates success or failure. So there is one best practice. You can declare an instance, as I show at the bottom, of disjunction of error and success. And that's fine, but it doesn't read really well. So instead we can use the infix notation, which is the top example, where we say error, disjunction, success. So you have your left-hand value, the disjunction operator, and your right-hand value, or your types. And so this reads really well. Somebody who's familiar with disjunctions is going to look at this code and say, oh, it's going to be an error if it's a failure or a success. And so, it's an aesthetic choice, but you're going to get a bigger readability option, I think, if you go down that road. So here I can use the disjunction, and I'm just going with the flat out wildcard imports of import ScalaZ lowercase, and then you import capital ScalaZ to get a bunch of the implicits and objects and other things. You can do more discrete imports. I don't think it's useful for us to go down that road right now, so let's just assume we're going to import everything and figure out what we need later. So I can invoke on any value in Scala .write once I've imported these implicits, and I will get an instance of a disjunction right-hand side of whatever that value is. So in this case, success.write is going to give me a right disjunction of success. Or I can say failure.left and I'll get a left disjunction of failure. So these postfix operators allow us to convert an existing Scala value into a disjunction, to project something that we can use as an error. And so often you're going to find that you need either the postfix operators or the constructors to return the values out of your function that represent the disjunction. Now, not everyone likes the readability of this, of having this at the end of a statement, and so there are other constructors that we can use. You have a couple of different options. So you can say value.right, value.left, Or you can say disjunction.left value, disjunction.right value. It gives you the same result. It's just probably going to be a little bit clearer that you're talking about a disjunction here, because we've called a constructor on the disjunction object. Finally, we can construct left and right values directly. I don't recommend doing it. The recommendations I got when I started was don't do it this way. But you can if you want to, because left disjunction and right disjunction have constructors. And I can say dash / failure / dash success. And I'll get back the same result. And this is fully symbolic, and that goes down that road of people starting to get worried that you're using all these symbols they don't understand. So think about these two other options as something that might be a little bit more useful for you. So you've got dot right, dot left, or disjunction dot left, disjunction dot right. Now I want to digress a little bit, because this isn't very useful unless we think about how we can pair this with the pieces of our system that we already have. You're probably not going to go in, tear out all of your code, and put ScalaZ in tomorrow. Is anybody planning to do that? Okay. Hopefully not, because that wouldn't be a really good engineering practice. But you might want to start to introduce this to places where you've already got things like option. As Scala programmers, we probably are using option quite a bit. I know I do, because it's a good container for indicating success or failure. So it has a none type and a some subtype. None represents no value, but because it's an object, we can invoke methods on it and not have a null pointer exception. Some represents something that has a value in it. Like a disjunction, it actually has a bias towards some. You can iterate over it and get back the value if it's there, or nothing. The problem is with comprehending over an option that you get undiagnosed aborts. And what I mean is, if there's no value, your loop may exit without a whole lot of information as to what went wrong. So let's look at this example. I've got a couple of case classes. I've got an address that just has a city in it, a user with a first name, a last name, and an optional address, and then a DB object, which has an ID, and a user object, which is optional. So I've created the user Brendan with no address, and I've created some other guy that has no entry for the actual user. So I've got two things here that I can use to dig deeper into options and see how they're going to be used. So I've got a for comprehension here at the beginning, which extracts DAO from the Brendan object, which means that I should get that database object here, the DB object that's inside of the sum. And then I call DAO.user. Now remember, user is an option. So in this case, there is a value for user, so I get back an option of user from my for comprehension with the Brendan user. But what if I go through some other guy? Some other guy didn't have a user object. And so I get back none. But where did I get none? Was the database object empty, or was the user object empty? Or if we have 5 or 6 or 7 layers of comprehension statements, we have a lot of trouble tracing down exactly what went wrong and where it went wrong. And so this is where disjunction can come to the rescue. Because comprehending over these groups of options leads to a silent failure. I don't necessarily know which of my options failed to extract. And I might want an error message, for example, that tells me what happened. So ScalaZ includes some implicits to let us convert between options and disjunctions. The right bias of disjunction makes it easy to comprehend. Just like an option, we can put it in a for comprehension and have it extract. On a left, though, left has a value instead of none. It can have a string message or an exception or something that tells us what went wrong. So here, I start to introduce a couple of operators. There's two different ways that I can do this. I can convert with a symbol, \/ greater than, or I can explicitly say to right disjunction. Again, with the symbolic stuff, it's really going to be up to you. Now here's the thing that you have to think about. I converted a none to a right disjunction. What I'm actually saying here is here's an option. I want you to try to make it a right, but if it can't be converted to a right, use this argument to represent the left. So what I'm saying is convert the none to a right, but if you can't make it a right because it's a none, then return this error message as the left-hand side instead. And so none to right disjunction, no object found, is going to give me a left-hand side of no object found. But now I've got an error message that I can do something with. And a sum to right disjunction is going to give me the value. So in this case, my hovercraft is full of eels, which is a very useful value. The same thing for I will not buy this record, it is scratched. So with this, we get back a valuable error message that we can use in a lot more powerful ways than what we get with option. So I can iterate over these and extract them out where I get a DAO, but if there is no user object, no database object, I get the message no user by that ID. If there is no user object in that database object, I get back the message join failed, no user object. And so with the first one, I still get back a right disjunction of Brendan. But with the second one, where we got none back the last time and we had no idea where that failure may have occurred, I get back a left disjunction, but it contains the message that the join failed, there's no user object. So suddenly I have a lot more useful information. But what if we want to do something beyond comprehensions? And there's options to do that. There's some other interesting pieces that come together. So validation is there's only two pieces of ScalaZ that we're going to talk about today. The first was disjunction and the second is going to be validation. So there's not a whole lot that you have to understand as far as I'm not going to show you 80 different pieces of ScalaZ. This is the second one, and this is because they're complementary. I started using validation and then found that validation couldn't do everything and ended up using disjunctions a lot more. Validation looks similar to disjunction. It has the extra benefit of not being a symbol. So it's a little easier to comprehend what's going on. And you can convert between disjunctions and validations. The validation has subtype success and subtype failure. So it is not a monad, although I found when I was starting, I found a whole bunch of examples out there of validation with ScalaZ 6 that showed it as a monad. I think somebody told me that was a mistake that had been corrected in 7. It was described to me as a mistake. So validation is not a monad. What it is an applicative functor. And so those are the two major scary words that I'm going to use here. We have a monad for disjunction because we can do things with it and comprehend over it. Validation lets us chain operations. So if any failure happens in a chain of validations, the failure will win. All the errors get mashed together. So I've got a couple of sample objects again. We've got a user for me, Brendan, the city that I live in, Sunnyvale. We've got Cthulhu, who lives in Relia, or sleeps there dreaming. We've got no such person, who has no address and isn't a person. And then we've got John Pretty, who has no address because he's been roaming the planet doing awesome talks and other things for a while now. So we've got 4 example users here that we can do things with validation. Because there are multiple components. Is there a user object? Is there an address object? So I've got a function valid DB user, which given a DB object will either return success with that user object or failure with a message as to why it failed. And this returns a validation of string and user. The first argument, the first argument being the failure condition and the right-hand argument, the second argument being the success. And so if I call valid DB user Brendan, I get a success of a user. If I call valid DB user Cthulhu, I get a success of a user. Valid DB user of no such person gives me an error message because that DB object has no user. And then finally, a valid DB user for John Pretty returns a success of user. So this is a more complicated function. I've got a little bit of guard statement in there. The gist of it is this. I'm validating a user object to see if they have a valid address. So if I find an address in my user object, I call a function that checks if the post office considers it to be a valid address. If it does, then I return an address.success. So this will be a success object containing the address. If it doesn't, I return a failure of invalid address. If there is no address, we return a failure of no defined address. And then finally, we can return no such user if there is no user object. So if I go through the chain of these, Brendan gives success because there's an address in there. Relia has no mail carrier. Nobody wants to deliver to wherever Cthulhu is sleeping. So we get an invalid address not recognized by postal carrier. The no user, the user that has no value, is no such user. And then finally, John gets a no defined address because we don't have an address on record for him. Now I can stick these all together, which is where it gets really, really interesting. ScalaZ has a number of applicative operators that can combine results. The two big ones that you need to keep in mind are star greater than and less than star. Star greater than takes the right-hand value and discards the left if it succeeds. And less than star takes the left-hand value and discards the right if it succeeds. The important thing to remember here is that errors win. If something goes wrong, then the error is going to win out and be passed up to the top. And I'll show you what I mean. 1.sum, right, 2.sum, is going to give me the right-hand side because the right-hand side was there and there was no error on the left. Doing the reverse gives me the left-hand side because the left-hand side wins. Now if I say 1.sum less than star none, even though the left-hand side is supposed to win, there was an error on the right, so we never actually get to the left. And then the reverse is true for star greater than. Now, this is not terribly useful on its own. This is probably a bunch of gibberish that isn't terribly useful as a slide, but it's about to show its use as we look at how we can use this in real code. With validation, it's going to chain all of these things together as errors that occur instead of short-circuiting. So, valid DB user, right-hand valid address, is going to give me a success of the right-hand side because I'm saying the right hand wins, and so I get back a success of an address. For Cthulhu, it's going to still give me the right-hand side, but it's a failure because the left hand succeeded, the right hand failed, and so on and so on. But now there's an interesting question. Does everybody see this last one? The error message is DB object does not contain a user object, no such user, all mashed together, which isn't terribly useful, but this is the behavior that happens with validation under the covers. And so the way that star greater than is called on validation appends all of the errors together. Within ScalaZ, the behavior that occurs with appending is actually defined within each operator, and so within each object, and they can decide what they do. In this case, validations append together with whatever their internal object is. So we need one more tool. And I lied when I said that I was only going to show you two things, because I'm going to show you NonEmptyList as well. NonEmptyList is just a list with one extra condition. It has to have at least one element. You cannot instantiate a NonEmptyList with no value. So if you get a NonEmptyList, it's guaranteed to have at least one value in it. So think about that for error messages. If you get back an instance of NonEmptyList, you know there's at least one error contained within it. This is commonly used with validation to accrue error messages, so I can stack up a bunch of error messages together. It's so common, in fact, that there's an alias of validation NEL, so that you don't have to say a validation of NonEmptyList. Validation NEL is the shortcut. And when you call append on an NEL, it works just like it does on a list, where it's going to add each element together separately. So here, I've changed over my valid user object, my valid user method, to return a non-empty list of failure. Now I can be explicit and construct a non-empty list and declare it explicitly, like I've done here on this last line. Or I can use some shortcuts. In this case, I've got .failure NEL, which is going to construct a failure of non-empty-list. There may or may not be a readability issue here. It's really up to you to decide whether you think being explicit is better than this postfix operation. Different people have different preferences on this. Now, if I put these together with a non-empty list, instead of getting that mashed together string, I get a list of errors. So imagine if I chained together 10 or 15 or 17 validations, that I could get back an error message with each thing that went wrong and solve that instead of solving one problem and then fixing the next and then fixing the next. I could say, hey, here's all the things that went wrong. I can validate a web request and look at the conditions and go through everything. So there's one last operator I'm going to show you, which is the pipe operator. This is when I want to combine all of the success and all of the failure conditions. And to handle this, we provide a partial function. So I've combined together valid DB user and valid address and provided a case statement which will say that user blah 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 lives in address. So user Brendan McAdams lives in Sunnyvale. The other users are going to return an NEL of errors, just like we get with star greater than. If it succeeds, our partial function gets each of the conditions that succeeded in order to operate on them, like I get here. But if it fails, then we just get back to the validation NEL. Finally, one last quick function. And I'm just going to talk through this quickly and probably skip over a couple slides because I think we're short on time. Dealing sanely with errors is a challenge. How do we do this? So there's a couple of ways in Scala. We've got things like scala-util-try, which is perfectly fine and useful. But if we're already working with disjunctions, if we're already down in the ScalaZ world, there is a higher order function called from try catch throwable. This will catch any exception that you specify and return a disjunction. So you will specify your return type and the types of exceptions to catch, and then a function body, something to call. So foo.toInt, here's my example. I'm trying to convert a string to an integer. Obviously foo is not a number, and I'm going to get a number format exception. But if I wrap this in from try catch throwable, and I specifically said I want to return an int and I want to catch number format exception. And so the result of this statement is going to be a disjunction of left with a number format exception in it. But it hasn't been thrown, which means I don't have to catch it up the stack or worry about it bubbling up. I get a disjunction back instead. I can do this as well by making myself less specific. I can just say catch all exceptions, and it will catch this as well. And then finally, I can say illegal argument exception, and I'm going to get an exception. Actually, interesting. Is number format exception an illegal argument exception? I didn't look at that slide, clearly. That was a bad example because it didn't do what the slide was supposed to demonstrate. I apologize. But there is specificity to these. Illegal argument exception and number format exception shouldn't be the same, although I think in this case they are. But if you don't specify an exception that's what's thrown, it will throw back up the stack. So the type matters. If a thrown exception doesn't match, it's still going to be thrown. There's one more, which is from try catch non-fatal. There is a construct in Scala called scala-util-control non-fatal, which allows you to specify, there are certain exceptions which are not considered runtime errors. And so if you say try catch non-fatal, you only have to specify your success type, and the rest of it will bubble up and passed. But in this case, anything that's not non-fatal will be caught and returned in a left disjunction. So I have a final thought, and this is about names. You've probably noticed there's a lot of symbols here, and I didn't always have the easiest way of describing, like things like star greater than or pipe at pipe. So the common use of symbols gets really interesting when you've got a team of people who all have to communicate with one another in something other than random symbols. So at least agree within your team that we're going to call this thing this, and everyone is on the same page. Although it's defined in either.Scala, calling disjunction either is going to get confusing because there's already an either in Scala. Now, my favorite example is there's a bunch of names that I've heard people call the pipe operator. Some of them I added today. Dick Wall gave me at least one, and there were a few other people who added them, so I keep adding them to this talk when everybody comes up with a name. There's actually also a Unicode alias, which is a star inside of a circle. So if you really wanted to go Unicode-y, you could do that. So here are some of the names I've heard. Oink, because it looks like a pig's tail. A Cinnabon, actually I'm the one who called it a cinnamon bun, so I'm cheating here. I thought it was a Cinnabon. Dick pointed out there's something called a Chelsea bun in Britain, which is really a pan au raisin. It's just a raisin horn. Jason Swartz called it a TIE fighter when we were first looking at it. I liked TIE fighter. I thought that was a pretty good one. Princess Leia was pointed out to me earlier today. Admiral Akbar, I forget where that one came from, but I heard somebody call it the Admiral Akbar. Scream. Scream 2. Home Alone. And I'm throwing Pinkie Pie in there because my talk needed one more pony. So that's really what I have. I know that's a lot of information packed into a very short amount of time, but hopefully there's some questions. How are we doing on time for questions? Okay, so if there's any questions, now's the opportunity. I think there's microphones up along the sides here. Feel free to step up and ask away.
Yeah, a couple questions. The first is, I've found that even with relatively self-contained features, ScalaZ, validation being the canonical example, there are a lot of idioms that you sort of need to grok in order to use it effectively, or at least to make sense of the code. Like if you do go to definition even once, you're going to run into, you know, monoids at the very least. Yeah. How have you dealt with this with respect to other teammates in your experience? So
we had a pretty small team. There was probably 3 people who were coding every day and a manager who was coding sometimes. Really part of it was just gently introducing things, of trying to say, hey, I'm trying this thing, can we look at it? I don't know that we dug a lot into definitions where we had to deal with monoids or anything else. We really started with using validation in order to show different things and then introduce disjunction. We tried to keep it relatively simple, tried not to go down the road of looking at all these different terms. I may not be the best example. I may not, my colleagues may tell you that I did a terrible job of introducing this. I thought that it worked well for me, but part of it was not going down that heavy road of we're going to pull out category theory books and worry about all of these terms, and looking more at this is the practical use of this piece of the tool, and this is how we can get benefit out of it. I know it's not a great answer, but it was the road that I went down in order to approach this.
Okay, second thing, it's not really a question, but awesome Fallout shirt.
Oh, thank you. I've not always noticed. I thought maybe people would think it was a California Republic shirt, but NCR.
Is disjoint the only thing you found useful, or did you just show that today, but you actually use ScalaZ?
So there are some other things that I've played with lately. Rob Norris wrote a really awesome library called Doobie, which is a SQL library, and he's done some very, very cool things with ScalaZ that I've been starting to dig into his source code and see what he's done. There's things like a macro that lets you say SQL is string interpolation and does all the prepared statement stuff. There's also ScalaZ task. Tim Parrott wrote a really, really great article on ScalaZ task, which is a framework for running operations, whether they're synchronous or asynchronous, and getting back disjunctions and other things. If you really want to see more about that, it's really easy. Just search Tim Parrott ScalaZ task. I think he's got like the ScalaZ task, the missing manual. So I've been starting to dig into little things, but what I found the most useful for actually deploying code that I built a system with was disjunction and validation. The rest of it has mostly been idle curiosity, and I haven't quite figured out how to tie it all together yet. Any other questions? All right, well, thank you for your time and have a good day.